So today we're going to do our last topic on absolute values. So far we looked at what an absolute value was. So if you have something like absolute value of -5, remember that makes it positive. And if we do absolute value equations, something like that, remember we have to do the positive version and also the negative version. Because the absolute values can be plus or minus, we have to actually solve for both. So in this case we'd have x plus 2 equals 7. So x would equal 5, and for the other one we'd have minus x minus 2 equals 7. So we'd have minus x equals to 9, or x will equal negative 9. And if we plug both of those into the equation, they both will work, so we get two different solutions. So our last topic now is we're going to look at what an absolute value graph looks like. So this would be the same type of thing, but absolute value of y equals x minus 2. So you can see on the graph we get this sort of weird V-shaped thing. We try a quadratic, like x squared minus 3x, you can see we get sort of, it looks like a W sort of shape. So we're going to try to figure out what's going on, why do we get these kind of weird looking graphs when we do absolute values. So remember, an absolute value graph just means anything inside the absolute value becomes positive. So in terms of a graph, that means any negative section of the graph will turn positive. So if we graph just the original 2x plus 3, y equals 2x plus 3, we get a diagonal line that looks something like that. We know just from solving it that our x-intercept would be at negative 1.5, right? Our intersection point would be the opposite of the 3, so negative 3 divided by that 2 in front. So negative 3/2 or negative 1.5 is our x-intercept. We know from also looking on the graph that our y-intercept would be at positive 3. And other than that, it's just a straight line that goes through those. So now if we actually try to graph absolute value of 2x plus 3, what we're seeing is the graph does the exact same thing. It looks like the exact same graph, but as soon as we get to the negative section of the graph, it gets reflected upwards because any of those coordinates that are negative, the absolute value is going to turn them positive. So this coordinate down here that's at negative 2 gets reflected upwards, and it's now at positive 2, and so on. So all that means is that any straight line linear graph will go until it hits the x-axis, and then it's going to reflect upwards. And quadratics work pretty much the same way. So if we graph a quadratic of x squared plus 3x minus 2, we would get our U-shaped graph, something like that. And we could actually solve these things. So if we try to factor or use the quadratic formula, we would get our two intersection points. So it looks like this one's decimals, approximately 1/2 and negative 3.5. But once again, our absolute value is going to take any of that negative graph and make it positive. So all this whole bottom part of the graph will be flipped vertically. So it'll be flipped right side up. So our absolute value graph looks pretty much the same as the quadratic, just that bottom section gets reflected above the x-axis. So because we're flipping those things, those x-intersection points, those x-intercepts, become key points. We call those our invariant points because those are the two of the graph that stay at 0. The absolute value of 0 is 0, so it doesn't matter which graph it's on, they're going to stay the same. So those two intersection points will be key to calculate. So let's actually, before we do that one, let's look at a different one. So if I gave you an equation of absolute value of x minus 3, we know that from that our invariant point will be 3, right? X is 3, that's when y will be 0. We know it's a straight line, so it'll be something like that. And we know the absolute value is going to make it positive, so we'd have our V-shaped graph, something like that. If we try, let's try one more with a quadratic. So if I gave you an equation that was y equals x squared minus 4, we know that quadratic, if we solve that, we would get x equals plus or minus 2. We know our y-intercept is negative 4, so we know our quadratic would go through those points from negative 2 to 2 and down to negative 4. So if we actually changed our quadratic to be absolute values, all that's going to do is reflect that bottom part up to positive 4. So our absolute value graph would be our W shape on the top, and the whole bottom part would be gone. So the x-intersection points, very important still once again, and now we just got to worry about the reflection. So another way of writing these is what we call piecewise notation. So what it means is we just write the absolute value as two equations that are normal. So if we graph y equals 2x minus 1, 2x minus 1, our intersection point would be at a half, so we know that's where our invariant is. And we know it's going to be sort of a V-shaped graph looking something like that. So if we actually try graphing this as just 2x minus 1 as a regular graph, we put that in our calculator, what that's going to look like is it's going to be a graph that goes through that line there. So you can see this actually is the exact same equation if we only look at the right part of our graph. So that means 2x minus 1 is the correct equation if x is greater than or equal to 1/2, right? Because that gives us that exact same line. If we graph the negative of the original, so minus 2x minus 1, you can put brackets in like that. If we graph that one in our calculator, we actually get a line that does the other section of it. So you can see that these two portions of the graph are exactly the same. So that's going to be the correct graph if x is less than 1/2. And you can put equal to, because they both, that half is actually on both lines. So you can do it on both, or what often is common is we just do 1 with equal to and then 1 without. But that's it. That would be our correct equation for piecewise. So what you need to remember is just take your original absolute value, write it as a positive, write it as a negative, and then just figure out where it's greater than or less than compared to that x-intercept. So let's do another one here. So our piecewise, we know we're going to get minus 2, x minus 4. So the minus 2 up front doesn't do anything. It's going to change our graph, but it doesn't affect our equation at all. So just leave the minus 2, and we'd have a positive of that brackets, which is the same thing. And then we'd have minus 2 of the negative of that brackets. But if we put a negative out the brackets, that would be the same thing as just making it plus 2. So the negative just sort of changes the order around. The positive will be the bottom one this time. So once again, if we graph this, so if we graph x minus 4, we have a x-intercept at 4, and if it's negative 2, in this case it's actually going to be upside down this time. So we just got to be a little bit more careful. So now if we graph minus 2, x minus 4, that will actually be this side of the graph, so that would be the same as that one. So we would say if x is greater than or equal to 4, and if we do the positive, 2x minus 4, that's going to give us this other side of the graph. So that bottom part will be the same. So that will be when x is less than 4. And that's it. So that's your piecewise. So you can see, just always do the positive or negative version of the original, and then just go less than or greater than whatever that x-intersection point is. So now quadratics work almost the same. So let's look at this one again. So if we graph this one, we already did this one earlier, so we know our x-intercepts are at 2, negative 2, and our y-intercept would be at 4. So when we graph this one, we're going to go down, but instead of going down to positive 4, we're going to go up to positive 4 there, and then something like that. So that would be our absolute value graph. So in piecewise, we're going to write it as x squared minus 4 as the positive version, and then negative x squared minus 4. So now we just got to be careful of our greater than less than part. So x squared minus 4 will actually be a graph that looks like our normal quadratic. So that would be sort of like that. So where is that graph the same? You can see it's the 2 arm part of the graph. So in our W, so this section of the graph is the same, and this section of the graph is the same. So the original and that positive version are going to be the same only when x is less than or equal to negative 2, that's the left side, or positive greater than positive 2, that would be the right side. So we actually have to put in both of them. Then when we do the second equation, if we were to graph the negative equation, that's going to be our quadratic that goes upside down. So in the negative version, the overlap is going to be just in the middle part. So how we write that would be the reverse. We'd say x is greater than negative 2 and less than positive 2. But we typically don't write it that way in this case. There's a shortcut. We write it as minus 2 is less than x, which is less than 2, which basically means x goes between negative 2 and positive 2. So both of those are the same thing, but this second version is the way we typically would write it. So let's do one more. Here we got minus 2x squared plus 9. So let's think about what our original would look like. So our original would be, it's going to go up through 9 and negative 2, so it's going to be an upside down quadratic, something like that. So our absolute value is actually going to be a W shape again, but you can see this bottom part would reflect up, our middle part would be the same, and then this other part would reflect up. So in this case, when we write our piecewise, the original graph is the middle this time. So we'd say our minus 2x squared plus 9 will be the middle part. So all we got to do is figure out what are those x intersection points. You could do this on your calculator, or let's solve it mathematically. We want to figure out where that's equal to 0. So we'd have 2x squared equal to 9. If we bring it over to the other side, divide by 2. And we need to square root both sides. So if we square root 9, we get 3, plus or minus 3. Divide by 2, square rooted, we'll just leave it like that. So there's a couple different ways of writing it. You could do decimals, would be fine, but let's do it as plus or minus root 3 over 2. So that's our negative, this one would be our positive. So you can see now our original graph is overlapping the same in the middle, so that'll be between negative 3/2 and positive 3/2. Square rooted. And our negative version of the graph, in this case, will be the arms. So that's going to be where x is less than negative 3/2 as a root, and where x is bigger than positive root 3/2. And that's it. That's our piecewise. So piecewise, you want to remember to do positive and negative, and then just figure out where your x intersection points are and figure out which graphs are the same. Is it in between the two or outside of the two? The greater than less than notations, it gets a little bit tricky, but once you do a few of these, you'll get the hang of it. And that's all for absolute values.